This is Health Matters, a podcast from Mayo Clinic where we discuss the latest medical advice, news, and research to help you live a happier and healthier life. My name is Kristen Meinzer. I'm a writer and journalist, and this episode, we're talking about the gut microbiome. On a practical level, the colon might seem like just a long tube, but in recent decades, we've realized that we've been missing something important. It contains a whole ecosystem that's right under our noses, almost literally. Each person's gut is teeming with bacteria, fungi, viruses, and parasites that make up a unique microbiome. This gut microbiome influences our digestion, our immune system, and even our overall health. And it could hold the key to treatments for chronic illnesses. Here to lead us into this new microbiome frontier is Dr. Sahil Khanna. Dr. Khanna is a gastroenterologist and hepatologist with Mayo Clinic in Rochester, Minnesota. Not only is he an expert on the colon, he has special interest in the gut microbiome and works with microbiome-based therapies like fecal transplantation and more. Dr. Sahil Khanna, welcome to the show.
I'm so delighted to be here. Thanks for having me, Kristen.
Well, I am delighted to have you because, believe it or not, I love talking about colons, and I'm excited for us to talk about what's inside of our colon, other than waste, that is.
I do believe the colon is the most interesting organ in the human body. It has way more functions than being just a long tube. It's not just a waste pipe. It's a living, intelligent organ in itself, but also harbors a more intelligent organ inside it, which is the microbiome community.
What is the gut microbiome?
The gut microbiome is the vast and complex community of microbes that reside in our body. Bacteria, viruses, fungal organisms, certain protozoal or parasitic organisms that just live in our gut. It's estimated that a human being has anywhere between 50 and 100 trillion microbes that live in our gut.
Wow.
They form an ecosystem like a gut rainforest that's essential for our health. And just like a rainforest, where the more species, the more plants and animals that we have is better for the survival of a rainforest, the more species of gut bacteria that we have, it is beneficial to human health.
I think a lot of people, when they hear bacteria, they think, oh, no, that's a bad thing. But they have functions that are actually beneficial to us. Tell us more about those.
We believe that 99% of those bacteria that live in there are beneficial to the human body. They're not just inert and sitting there and feeding off us and being alive. They help break down a lot of carbohydrates, which we eat. These microbes help produce many vitamins that the body needs, produce many short-chain fatty acids, which are very essential for functions of the body, metabolize some drugs, and very importantly, maintain the lining of the gut so that things that should stay in the gut stay inside and things that should get absorbed, get absorbed. This function is called the gut barrier. And the gut bacteria, they help with what we call immune tolerance.
What does immune tolerance mean?
So we're exposed to our environment all the time. Everything that we're exposed to is potentially foreign to the body, including everything that we eat. And the body could react to it. The gut microbes have a function called immune tolerance, where the body doesn't react to everything that's foreign, and we're not having allergic reactions to everything that we touch.
So without the gut microbiome, we'd have to live in bubbles all the time because our body would be reacting to everything that isn't part of us. That's a pretty important job.
The gut microbiome is not an innocent bystander within our guts. It's actually an active organ in itself. And it's more active than the genes that are in the human body.
But question about that. Genes are things we're born with. Microbiome, are we born with those, or are those things that we develop because of our lifestyle or our environment?
So both. Before birth, in the mother's uterus, living beings are sterile and have no microbiome.
Oh. Oh,
And there's science out there right now which says that if you're born vaginally versus through a C-section, you acquire different kinds of microbes. During the process of childbirth, you start acquiring microbes from the mother and then eventually from your environment. It's estimated that in the first year of life, you pick up a lot of different useful bacteria, and the microbiome is very rapidly changing. Then, between that and early childhood, the microbiome changes, but not as rapidly. When one's an adult, you get into what we call as a healthy, stable state of the gut microbiome. And as people get older, then you start getting a lower diversity or lower number of microbes after the age of 65 or 70. And it's very important to pay attention to the gut microbes as one is growing because exposures during childhood, antibiotics, diseases, illnesses can affect the gut microbiome. Certain science has shown that people who get more antibiotics in the early part of their life can develop certain diseases like allergies, eczema, inflammatory bowel diseases. And is there a correlation there with the gut microbiome or not? That science is still evolving. To answer your question, we're born with genes.
mm-hmm.
The microbes have 150 times more genes than what the human body has. And those are dynamic genes because you can pick up some microbes, you can lose some microbes. And when you do pick up healthy microbes, you just pick up more useful genes.
Well, how can we all pick up more useful microbes? Does it have to do with our diet? What's going to make my microbiome more diverse and more healthy?
You feed your microbes with good habits, and they start improving the diversity, and the good microbes start growing. That's the best way to think about it. How do we feed our microbes with good habits? Diet is the most powerful factor. Plant-based diet, high fiber food, things that are rich in different colors, berries, strawberries, other kinds of fruits, different kind of fermented foods, yogurt. These help with the diversity of the gut microbiome. You flip it around, a diet that's high in sugar, high in fat, high in processed foods, high in emulsifiers, unfortunately reduces the diversity and encourages the growth of undesirable microbes. Many other factors are also important. How much stress we have, how much we exercise, how well we sleep. Believe it or not, people, when they travel to other parts of the world and are jet lagged under different time zones, that microbiome diversity takes a hit.
The poor microbiome are like, this is so stressful, and they die?
They don't like to live. They don't like to be happy. The numbers go down. The diversity goes down.
Oh.
It does unfortunately happen. The more stressful our life is, that actually really decreases the variety of the gut microbiome.
So we've got diets and stress. What else?
Environment matters. It's been shown in multiple studies that people who live in rural areas actually have a more diverse microbiome than people who live in urban areas. If you have a pet, you actually share a lot of your bacteria with your pets, and you could have better diversity than people who don't have pets. Another reason to have a companion, I guess.
City people, do they have less diverse microbiome just because they're not around farm animals? Or is it something about the urban setting?
So a bit of both. You are in an environment that is rich in diverse microbes that you pick, but also living in urban areas comes with everything else. Suboptimal diet, more stress, lack of exercise, that really decreases the variety of the gut microbiome. The elephant in the room is antibiotics.
I got to say, I was raised in the generation where if I even sneezed, I was given that pink amoxicillin as a little kid. And I'm curious what effect antibiotics might have on one's microbiome.
First of all, antibiotics are life-saving. Average human lifespan has gone up across the world with antibiotics because infectious diseases have been the biggest killers. Surgeries have become more sterile. Lots of advantages of antibiotics. Probably about 20, 30, 40 years ago, the pendulum started swinging to the direction where, as you mentioned, you sneeze and you get an antibiotic. I think that's where trouble started. The Centers for Disease Control in the United States estimates that we write 270 million antibiotic prescriptions every year in the United States. Our population is about 350 million, give or take.
Wow.
That's a jaw-dropping number.
So all of us on average are on antibiotics every year.
On an average, yes, but I wouldn't say everybody is because a lot of people get more than one course of antibiotics.
So it sounds like overprescription's a big issue. How are antibiotics being used incorrectly versus correctly?
There are principles with antibiotics that need to be followed. Antibiotics are for bacterial infections, not for viruses. Viral infections are more common than bacterial infections. So one needs to make sure this is suspected bacterial infection. Antibiotics can be used to prevent infections and should be used to prevent infections, especially in surgical settings. The other principle with antibiotics is that there are certain antibiotics that are narrow spectrum, meaning they kill certain bugs. They'll kill the pathogens, but they also kill good bacteria. And you need to narrow that spectrum as much as possible, and then using them for the shortest duration of time as much as possible.
So if I end up needing to take an antibiotic, is there anything I should do to replenish my gut microbiome? Is it helpful to take a probiotic at the same time, for example?
Majority of the times, if you take a probiotic with the antibiotic, it's not going to be helpful because the antibiotic is going to be likely killing the probiotic at the same time.
So should we take probiotics after we're done with the antibiotics then? Is that the best time to take them?
I think the science there is very mixed. There are certain studies that have shown that, yes, you could take a probiotic after antibiotics to combat some of the side effects of antibiotics. One of them is antibiotic-associated diarrhea, and probiotics may help. And this is the bigger question with probiotics. Are probiotics helpful? And we need to think of it in the manner of numbers of bacteria, variety of bacteria, and do they start living in your body? Humans have between 50 and 100 trillion microbes. Your biggest probiotic capsule will have 100 billion of something in there. Certain magnitudes off in terms of the numbers of bacteria. Most probiotics have 1 or 2 or 3 species. The ones that I've seen that have multiple species have probably 8 or 10. Our gut microbiome has between 500 and 2,000 species. Majority of them have not even been characterized. Majority can't even be grown in a lab. So you can't replace everything that you get from nature or your environment with a probiotic. And then thirdly, most probiotics don't tend to colonize with the rest of the bacteria that live in your bodies. Like if somebody asks me, should I just take a probiotic every day? I usually suggest that it's not going to be beneficial. It's an expense. There's certain instances where we say maybe you've got some GI symptoms and you tried a probiotic and that has helped with your symptoms. That's probably okay to take. I think the science needs to evolve further where we figure out what's the best way to cultivate probiotics, to give them to people in a way that they actually start living and surviving. But in current state, for the most part, underwhelming evidence for probiotics for general health.
Well, when I do take an antibiotic, how many of those 1,000 species of microbiome are going to die off from the antibiotic?
It depends on how broad spectrum your antibiotic is and how long you took it for. The longer you took it for, the more broad spectrum it is, the worse is the impact of the microbiome.
And what do we mean by worse impact?
Very simply, it's going to decrease the variety and the numbers of the bacteria. Not only in the colon, but other parts of the body also.
You can think of the gut microbiome as a diverse rainforest of microbes that help break down food, produce substances the body needs, maintain the gut barrier, and support our immune tolerance. And like any rainforest, you want both healthy quantities and a variety of species. We can feed our gut microbiome with good habits, healthy diet, sleep, exercise, and managing our stress. On the flip side, if we have a less than ideal lifestyle, our gut microbiome takes a hit. Then there's antibiotics. While antibiotics save lives, taking an antibiotic you don't truly need, taking a broader spectrum one, or taking one for a long time can all be detrimental to your gut microbiome. And the jury's still out on whether probiotics can actually replenish our gut microbiome. So we know how important the gut microbiome is. Let's learn more about common issues with it and, maybe you've guessed it already, fecal transplants. You've done research on a bacteria called C. difficile, or C. diff for short. What is C. diff and how big of a deal is it?
First reports came in the late 1970s in people who took an antibiotic and started developing diarrhea. And it was determined that this bacterium called Clostridioides difficile, or C. diff, causes human diarrhea. If you get exposed to this bacterium from your environment, it can cause diarrhea, abdominal pain. We know very clearly that if you have a diverse microbiome, C. difficile can try to colonize your body, but it won't be able to because the microbes will outcompete the C. difficile. When somebody's got on antibiotics or has other risk factors for C. difficile, there are many others. Antibiotics is one of them. Acid-reducing medicines, being sick otherwise, being in a hospital, being in a nursing home, age over 65, cancer diagnoses, immunosuppression. If you have those risk factors, the variety and numbers of bacteria go down. We see anywhere between 300 and 500,000 people getting C. diff infection in the United States every single year. That means the last 10 or 15 minutes of us having this conversation, there have been a few people who got C. diff somewhere. It's the most common bacterial infection in hospitals, previously affecting older people, but now also infecting younger adults in their 40s outside the hospital, sometimes even without antibiotics. And the CDC calls it an urgent public health threat.
Now, if I'm understanding correctly, the rise of C. diff is because of antibiotic resistance. Is that right?
So that's part of it, not all of it, because when you get too many antibiotics, many pathogenic bacteria can become resistant to that antibiotic. For example, would be if somebody has urinary tract infections, you get antibiotic for the first urine infection, the second one, third one, you see the resistance pattern change, and that E. coli will get resistant to that antibiotic. So the next time you have to use a bigger gun antibiotic, the next time you have to use a bigger gun antibiotic, and then you kill more healthy microbes and you can get C. diff. So it's an indirect result of getting more and more antibiotics.
And what actually works to combat it?
First of all, it's a bacterial infection that's caused by antibiotics, and we use another antibiotic to treat it.
Oh.
Which kind of is like oxymoronic. The truth of the matter is, once you have C. diff and get one of these antibiotics, there is anywhere between a 15 and 30% chance that the infection is going to come back on its own, even without having more risk factors. So if 100 people get C. diff, on an average, 20 are going to get it back the first time around. Of those, the second time around, about 40% will get it back. And the third time around, about 60% will get it back. And the reason people keep getting it back is because those antibiotics treat part of C. diff, meaning they don't kill the spores, they kill the vegetative forms of C. diff. C. diff is in two forms in our body. But vancomycin is a broad spectrum antibiotic that kills a lot of the useful bacteria that live in our bodies. So it gets a bigger hole. You're from Minnesota, you remember your Minnesota summers, you've got dandelions growing in your backyard, you put a weedicide on it.
Oh, yes.
You kill it temporarily. If you don't pluck it out, it's going to come back, and the weedicide is going to kill the good grass around it, and next time you get more dandelions in your backyard. That's what happens with C. diff. Antibiotics are ineffective.
So what do you do when that happens?
How do you actually get rid of the weed in your backyard? You pluck it all out, you go to the store, you buy good grass seed, you plant it, and then you feed it. And that's the concept that we've learned for C. diff infection also, with gut microbiome-based therapies, where we can actually change or alter the gut microbiome with treatments that are derived from healthy humans too.
I'm so glad you brought that up, because I am so curious about fecal transplants. Can you explain what a fecal microbiota transplantation is?
Fecal microbiota transplantation, we'll call it FMT.
Okay.
We are now calling these therapies as microbiota-based therapies, where we are deriving either microbes from human stool or putting collections of microbes together that may or may not have originated originally from human stool and trying to alleviate human disease from that.
So, how do you get these healthy microbes? Do you have to collect stool from certain people?
Majority of the times, these therapies are coming from people who are stool donors. Like you got blood donors, we've got stool donors. They're supposed to be very, very, very healthy people, young adults with no medical problems. So those people need to be passing the blood bank questionnaire, need to have no infections. Those people need to have no other illnesses, including being overweight or obese, having diabetes, high blood pressure, anxiety, depression. The list is endless. No autoimmune disease, no malignancy diagnoses, and the likes. Some studies have estimated that less than 5% of the US population is actually eligible to be stool donors.
Wow, you have to have really good poop to do this.
We've been taking stool from well-screened donors, processing them in stool processing facilities, and using them to replace or replenish the gut microbiome with endoscopic or colonoscopic approaches where you can put liquefied stool into somebody's colon who's recently had C. diff infection. So if I have a patient who's had C. diff infection more than once or twice, we start thinking about, let's give them good bacteria. They finish their course of antibiotics, and then we can do a stool transplant. But that's invasive. You can see you're screening every donor every time. It can be heterogeneous. You're doing a colonoscopy. Can you make it better? In the last decade or so, we now have had multiple clinical trials that have led to 2 FDA-approved microbiome therapies, which are available and approved to prevent and treat recurrent C. difficile infection. One of them is an one-time rectal enema done in office or at home. And now we have capsules that are again derived from human stool.
Capsules that we would swallow?
Capsules that we would swallow, yes. They are designed to open up in the latter part of your intestine, so they colonize the large intestine. The reason we're so excited about is one, yes, we can treat this deadly, devastating infection, but also this is the very first time that we can use human bacteria to treat an illness. So it opens the pathway for so many other diseases that are associated with the altered gut microbiome to see, can you make treatments better for other diseases by using collection of gut microbes?
Wow, I'm curious. What are some of the other diseases that researchers are hopeful about being treated with fecal transplants?
We're looking at GI illnesses, irritable bowel syndrome or IBS, inflammatory bowel disease such as ulcerative colitis or Crohn's disease. There is research in some liver diseases like metabolic or previously known as fatty liver disease. Some research is ongoing in people who have complications from alcohol liver disease. There's been research that's going on in metabolic diseases, including overweight or being obese. Outside of the GI world, there's a lot of research going on in some neuropsychiatric illnesses, including autism, Parkinson's disease. How do we improve cancer therapeutics? And then we've also looked at some research within other infections. A very small study done from our center here at Mayo Clinic demonstrated that people who have recurrent urine infections, if they got a stool transplant for another reason like C. diff infection, their urine infection frequency went down and the resistance of the organisms causing urine infections went down. So lots of different avenues are being explored.
Yeah.
I would caution at this point saying that for any disease other than C. diff infection, microbiome therapies should only be done under research settings. This is not DIY. Never DIY, even if there are YouTube videos on DIY fecal transplant.
There are so many of them out there. I'm glad you mentioned that because there are a lot of YouTube videos saying, this is how I use my husband's stool. And those videos kind of freak me out.
Please do not. You never know when you're going to get a harmful effect from that. I would suggest that if anybody is considering, talk to your doctor about it, find a clinical trial, do some of the research settings so it can be well monitored and taken care of.
C. diff is one of the most common bacterial infections in hospitals. In a healthy person, the good microbes can outcompete the C. diff bacteria. But if someone's gut microbiome has been weakened, that's when the C. diff takes hold. One of the most promising treatments for C. diff is fecal microbiota transplantation. But you can't use just any stool. It comes from donors with a clean bill of health who undergo rigorous testing. Previously, fecal transplants were administered using a colonoscopy-like procedure. But now we have enema and capsule forms that are FDA approved. Research is still ongoing, but fecal transplants might ultimately be able to treat more than just C. diff. We'll dig more into what the future holds, but first, let's bust some myths about how to keep your gut healthy. Let's move on to some myth busting, shall we? There are so many books out there right now saying, if you just eat these things, your gut will be perfect. Is there a perfect gut diet?
Sadly, there isn't a single perfect diet that works for everybody's gut. Our guts and the microbes that live in it are individualized. It's like you having your own fingerprint because of different genetics, different geography, different culture, different prior antibiotic use, different diseases that we've picked up throughout our life. But there are certain principles that help. Lots of plants, lots of diverse fibers, whole grains, nuts, legumes, Mediterranean diet. These foster gut microbial diversity. If I were to give a rule of thumb, try to eat 5 different kinds of fruits and vegetables every day. Try to get to 30 servings of fruits and vegetables in a week or more. More diversity in your food will lead to more diversity in your gut microbiome. And then avoid things that are in a packet that you can open. If you can't pronounce the ingredients, probably not a good idea. Excessive sugars are bad. That's been shown in a lot of different studies. There are certain diseases such as irritable bowel syndrome and celiac disease, talking to your physician, talking to a dietitian to see, can you tailor diet is very helpful.
Here's another one. I have been seeing a lot of advertisements over the last couple years for at-home stool testing services. You take your own stool sample, you mail it in, and the company promises we will tell you that your microbiome is healthy or not healthy. Are they able to test for just how healthy my microbiome is?
They can tell you what is the composition of your gut microbiome. Is that healthy for you or is that not healthy for you? That's anybody's guess. I think that's the problem there. I'll give you an example. We say that in normal adults, the range of hemoglobin or red blood cells product in our body is between 13 and 16. How do we get that range? Because this has been done over millions of tests over the years, and we know that a healthy person has this kind of a range in there. And we need something similar for gut microbes. A lot of those healthy ranges are based on very, very small studies. So you don't know when you say, I have this bacterium and it's out of this range. Is that range based on how many people? And for my health, even if I'm out of that range, that's healthy for me. So when patients bring that to me, I say, yes, you got it done. We know you have this and that bacteria. These tests are good to know, but not actionable, and sometimes can be anxiety provoking. A lot of these tests are not FDA cleared or FDA approved, so we may or may not know how accurate those reports are. I usually say, spend your money somewhere else.
All right. Is it worth then spending my money on a gut cleanse? There are lots of social media influencers saying the gut cleanse is the answer. What are your thoughts on that?
No. Please do not. Please do not. Please do not. So there's claims out there saying you'll use this gut cleanse, do a colon irrigation, take heavy doses of these laxatives. You will quote unquote detox your body. The body has inbuilt mechanisms to get rid of toxins. The liver metabolizes a lot of toxins. The kidneys get rid of toxins. You release a lot of those unwanted substances within stool. You really don't need to get everything that's in the large intestine out of it once or multiple times to get rid of toxins because your body's going to do that automatically. A lot of these gut cleanses have laxatives. They ask you to fast. They do colonic irrigation. This can actually be detrimental. If somebody has underlying GI illnesses like IBS, it can lead to flare up of these diseases. So I highly recommend not to do that. Now, some people need laxatives. That's a different story. If you feel you're somebody who's been needing to take laxatives for constipation or any other GI issues that you're facing, speak to your doctor about it.
Let's talk about where the research is headed. What emerging research or therapies excite you the most in the microbiome space?
Over the last decade or so, a lot of the bacteria that we are using in microbiome therapeutics have been derived from human stool. Research is now ongoing in a direction where we're saying, can we become donor independent for microbiome therapeutics? There is currently more than one manufacturers who are making these donor independent therapeutics, and they can manufacture that in a lab without wanting a stool donor every time when you have to make a therapy. So that's going to change the field forever.
Oh, and you already mentioned that there are clinical trials looking at therapies related to mental health, related to cancer, and so on. What are the applications in the future that you're most excited about?
I think for a lot of our diseases, we do have many well-defined therapies. Those therapies don't work for everybody. One of the first thoughts would be, can you augment existing therapies by changing microbiome or have that as an additional leverage? I think in the cancer space, one of the applications would be, can you augment response or improve or enhance response to a cancer drug by changing the microbiome?
Oh, fascinating.
There's been some preliminary work done with that. And then, can you combat side effects of cancer therapies by changing or giving microbiome therapies? Those are the two most important things that affect our patients who have cancer. But my hunch is that we're looking at several years. But between that and several years, there are clinical trials that people can participate in.
Do you envision a future where microbiome profiles are part of every routine checkup?
I think there is a future there, but we're not there as yet. We still need to define what's normal for the entire population. I think we're decades away from that at this time. But we're headed in that direction.
I do have to say, just the advances in the knowledge around all of this, just in my lifetime, it's been like night and day. I just don't feel like this was part of the dialogue like it is now 20, 30 years ago.
It makes it to the front of the New York Times or other newspapers multiple times a year.
All right. To wrap up, do you have any books or resources you'd recommend for folks who want to dive deeper into the topic of microbiome?
I've got a couple favorite books. One of them is called The Good Gut. It's by Justin and Erica Sonnenberg. They are researchers at Stanford University who have devoted their life to gut microbiome and how environment and food choices affect gut microbiome. Another one that I would recommend is called Missing Microbes by Martin Blazer, which talks about how modern society and antibiotics have led to microbiome changes over the years. There is great information that's available on professional societies, including the American Gastroenterology Association. There are resources available on the Centers for Disease Control website, professional healthcare organizations, including Mayo Clinic, Harvard, Stanford, others have all information on their website. And if somebody's looking for an illness that they or their loved one has, they're thinking of, can I get my hands on a microbiome therapeutic? The Clinical Trials Government website is very helpful in that situation.
Well, Dr. Sahil Khanna, this has been so enjoyable. I love your enthusiasm for our guts. I love your reassurance that we have a bright future ahead. Thank you so much. We really appreciate it.
You're most welcome. It's been enjoyable talking to you, Kristen.
So let's get a few things straight. There's no perfect gut diet. At-home testing kits generally aren't actionable information. And no, you don't need to do a gut cleanse or detox. most people can just stick to good old healthy diet, exercise, sleep, and stress management. But since research is ongoing, the story doesn't end there. We could be entering a future where we can derive treatments in a lab rather than using human stool. And maybe one day, treatments could help with everything from GI issues to making cancer therapies more effective. But until we get there, take good care of your gut and don't believe everything you see on TikTok. Okay, that's all for this episode. But if you've got a question, a topic suggestion, or a follow-up question about this episode, you can leave us a voicemail at 507-538-6272. We might even feature your voice on the show. And stay tuned for the next episode of Health Matters, all about blood pressure.
And as we were approaching the island, I was struck with sounds that I hadn't heard since my own childhood. It was children running around, yelling and screaming and having a good time playing.
For more information on the books and resources we mentioned in the episode, check out the show notes. And for more Health Matters episodes and resources, head to mayoclinic.org/Health Matters. If you found this show helpful, please subscribe and make sure to rate and review us on your podcast app. It really helps others find the show. Thanks for listening, and until next time, take care and stay healthy.